Hello and welcome to the next lecture. Today we're gonna add to our project from the Hibernate VM with Panache, Hibernate Search. So Hibernate Search is addition to Hibernate in some way. So it uses basically you can store data where you store it in a for example MySQL in our case, or Postgres or whatever. In case of Elasticsearch, in case of Hibernate search, it uses Elasticsearch for storing the indexes and search parameters for your database. So from the name, of course, Hibernate Search, you can understand that it helps to index all your data and make the searching faster. So it's basically the main idea of the Elasticsearch itself, but it's really helpful to know how to use the Hibernate Search for your project. So let's firstly create. Let's actually change our book a little bit. So instead of an author here, we're gonna have an author object. So let's firstly create new entity here. Firstly, let me make it like this, and then let's create a new class called author. And yeah, so let's create an author. So let's extend a Panache entity. We won't use a base because our ID, just a long ID, will work perfectly. And let's create a public string first, name, and the last name. And let's actually add a little bit more than usual. Let's create a public list of books. So this will be mapped by the so yeah, firstly let's add an entity here, and let's add a map. What is this? So we have an author, so it will be one author to many books, right? So cascade type will be we want to have all, I think. Then fetch, we will fetch it eager, and then orphan removal true, and target entity will be books. I think it should be mapped by the author, so we'll have an author in a corresponding field. I think it will show you that you can resolve attribute author, yeah, because we don't have it right now. But let's actually add also equals as well. So we'll use all the parameters here. Hashcode will be as well here. So yeah, we'll use the default one for the comparing objects. And yeah, that's it for the author. Let's move to the book. So in our case, the author won't be like this. We'll map it as well. So public author. So here we'll have the many to one correspondence, and then we'll also use a JSON transient. So this will help to prevent the infinity loop, so that it will firstly map the book and then the author, and then in author you have a lot of books. So this will help, right? So now we have our author entity with the one-to-many mapping to the books, and here we have, you can see that it's already not red for the map by, so we have this author here, and we can actually get rid of the page, and the ID will be as we had it previously with Panache entity, like this. So yeah, that's it. We can also remove get name, we don't need it anymore. So this will be like this. So we have a public name, author, and let's actually rename it to title just in case, so it will be more correct, because name of the book, it's more of the title of the book, right? So yeah, so we have a title, author, and then in the author we have first name, last name, and books. So now we need to add Hibernate Search itself. So again, you know, there is 3 ways to add. When you create a project, and it's not our case, we can use a Maven and we create add extension, sorry. Quarkus add extension, then you specify the extension, or in our case, because I know what to use, just copy one of the dependencies and just put the Quarkus Hibernate Search. That's it. So yeah, actually this Search Elasticsearch like that. So yeah, so now we can import everything, import the changes. It will load all the required data back to us. So let's actually start our Elasticsearch. I have here a Docker command that you can use to run it from the 9200, and then you have another port to 9300. So let's open our command line. So again, you need to have a Docker up and running. So just know that it's here, so you can check it if Docker PS is working. So we have here our Quarkus DB that we've set up previously. Don't forget to start it. If you forgot, you just use Docker start and then Quarkus DB. And so let's run our Elasticsearch. So you can see that we have Elasticsearch Quarkus test, discovery type single node. We have a parameter. Then we map two ports to localhost 9200 and 9300, and then the Docker image itself. So yeah, so let's start our Docker image. It will load some required data. In my case, it will load all the images. So let's just wait a little bit. All right, so once you see some logs here, because we haven't started detached, so you can see that we don't have -d anywhere. You will see that when you see some logs, for example, like security is disabled, activity list is now. So yeah, so this is running right now. We don't need to just leave it as is for now in some separate window. Yeah, so I'm here. So let's go to IntelliJ IDEA back and let's actually set up the application properties for it. So you remember we have a Hibernate VM dialect and database generation drop-in create for MySQL as it was previously, so it was yesterday, right? So now let's actually set up the analysis configurer. So this will be a config that will help the analyzers to know what to do. And actually you'll create the analyzers for our fields like book and author. So for some of them, their fields. So let's create actually config folder and then config analysis configurer like this. So this will extend Elasticsearch analysis configurer. I think it actually implements, sorry, Elastic search analysis configure like this, and we'll need to have a configure method for us. So I'll have here context. Let's rename it to context just so we can make it a little bit smaller, and let's call the context analyzer. So we need to specify our analyzers that we're going to use. So let's first one, let's create a name. So this is we show this custom, right? So we have a custom. Then we specify the tokenizer. So the tokenizer will be standard. And we'll specify the token filters as well. So there will be ASCII folding. The second one will be lowercase like this. And yeah, that's it. So let's create another one that we're going to use. Another role will be analyzer English. So this will go for the name of the book, right? So let's put a custom here. We'll have a tokenizer as well. Tokenizer will be again standard. And the token filters will be almost the same, but we'll have one more thing at the end, which called the porter stem. So this thing, this is the basically the token filter, which is not just you know, like a lowercase and ASCII folding. So the porter stem algorithm just strips out the end of the words by specific endings of the word, so that you'll have basically one word idea, but even though if the word will be different from time to time, it basically will match the same logic, right? And so the last thing that we need to have is we need to have a normalizer, context normalizer. We'll name it sort. So it will be again custom, of course. Here we only need the token filters. Actually, we will need them the same, like this, right? And the last thing that we need to do is to go to application properties, of course, and set up a little bit of configuration here. So I have some of the parameters here. So we have, as you can see, we specify a version here, so it's 7. And of course, if you go to the Elasticsearch, you will see that we have a 7.5.0 version. So we specified the analysis configurer, which we created in text.now config analysis configurer. Then the index the files lifecycle strategy for the Elasticsearch will be drop and create. And so basically it's the same thing that we use for the Hibernate VM. So it will drop on the restart, on the start, it will drop everything and create a new, recreate basically the database from the import SQL as well. And so it will do the same thing for Elasticsearch. Yeah, so this thing will specify that it's just helpful. So the required status, so there is a different statuses of the Elasticsearch. In the yellow is just like not ready completely, but it's like doable. So this will be helpful for the like testing like this, so you can play around. And then the searchable synchronization strategy is the automatic indexing. So this is basically it already goes to the Hibernate Search, and this will you can specify the strategy how the automatic indexing will work basically. So how you will index the data, and so yeah, so that's there. We can actually start our project. Let's call the Maven v Quarkus dev here. So you can see that we have an error, and it's actually because we changed the import SQL. So let's actually comment it out for now and to make it empty, right? Let's restart our app. Okay, so now our app is started, and we can close it for now. Just we need to ensure if it's working or not. Let's go back to IntelliJ IDEA and let's actually set up last part of our logic, which is we need to adapt our book and author for searching, right? So we need to specify that we want this field to be searchable. So taking the book, we want to make it indexed for the Elasticsearch, and so we want to specify how we want to index it. So the one option will be full text field like this, and so here we only want to specify the analyzer, and this will be English in our case, right? So the title can be in English words, and this is exactly what we've specified in the analysis configurer here. So we have an English, so it will do the IC folding lowercase and then Porter stem, so strip the ending on the words. And it's actually all for the books because we only have a title here. So let's switch to the author. So here we'll do almost the same thing. We'll create a full text field firstly, and then the analyzer will be in our case it's name. So we had a name, right? We have a name analyzer. So let's create a name for it. So the name will be the different name of the key. So for example, in our case, it will be first name sort, right? So the other, so we put here two keys actually, two fields for sorting. The first one is just the analyzer for the name, so we can search by name. And the other one keyword will be used for the sorting, only for sorting basically. So we can specify that it's sortable, so you can put a sortable yes, yes. And the last thing is what you want to specify is a normalizer, which will be in our case sort. So this is a normalizer that we created as well, so we can see normalizer sort. This will have a st folding lowercase in all the cases. So we will do the same thing for the last name as well, but the keyword will be a little bit different. So there will be last name sort like this, and everything else stays the same. And so one last thing that you want to specify is indexed embedded. This will specify that the one-to-many mapping that we have here the object itself, the book, will have the index as well, right? So we will index it as well from the author. So we'll know that, like, if we search from the author some title, we can check it as well. So we also want to do, so when we start the app and we import something from import SQL, it's empty right now, but I'll create something, come up with something in a second. I'll add the file later. So we want to listen for the startup event, public void on start, let's name it start, and then observes startup event. So now we can, firstly we'll need sadly to inject back the index entity manager, sorry. So we'll need to inject an entity manager back, and then now we can take the search from the search mapper ORM, as you can see, and then we put a session here from the manager, and then we do the mass index, called the mass indexer, and the last thing that we need to do is to start and wait. So yeah, we'll have an exception, I think. Yeah, sure. So let's just add the method signature here. So we want also to do it if we only have some books in our database, right? So we can call book. So if you remember the Panache ORM, so we can call count, and then if okay, so if book count more than 0, only then we execute this line, right? So this will, as you can see, it will start the indexer and wait, so it will be like automatically started, and it will analyze everything on the startup, right? And yeah, that's it. So the last thing that we want to do, of course, is to create a search, basically. So we created a lot of stuff, right? Now we want to create a search for us. So let's do it. Let's create. So it will be, I think, path. Let's search by the author, right? So we have book author search, something like this. So it's not correct, but it's better to put a /author search without the book, but I don't want to create another endpoint for now. So let's create a get, right, to produce the media type application JSON, of course. So we also need to specify a transactional interface here, because this will require transactional interface. So don't forget to put it here. So now we put transactional as well, I think, and let's return a list of books. So let's return a list of authors, because we search by author. Okay, list of authors. Search for authors, like this, I think. So we want to have a query. So let's query a pattern by which we will check it. So we'll have a query param pattern, string pattern, and we will also want to have a query param. What do we have? Size. Yeah. So we'll have a integer. Actually, we can do an optional integer size, like this. So this is okay. It shows that it's not intended to use there, but we can use it, of course, no problem. So yeah, so now we actually can use our search. So you can call this search, and then again this session, and we have here the entity manager, right? So it's called manager. So now we can search for the author class like this, and so you want to specify predicate. This will you can configure the search in here. Okay, like this. So now let's check if our pattern or if it's equals null actually, or pattern is empty. We can also, I think, trim it as well. Then we want to predicate match all. So this will search for everything basically. Otherwise, so we can put actually like this so to figure. So otherwise we want to query a simple simple query string, right? And here you can specify by which fields you want to search, right? So you can put the fields, and then we have the, so we search for the author. We can put a first name, last name, first name, last name, and then you also can specify a book's title as well. And then you specify that you want a matching and then pattern itself. So let me clear what's going on up here, and let's actually replace the expression with lambda like this, so we don't need to return anything, right? So now let me specify what's going on up here, right? So let's see. So so we have predicate, which is basically searching. It's like, you know, a proxy or something. So you specify what you want to search. So if the pattern is null or it's empty, then we match all. So we just return everything that matches the empty string. So basically return all, right? Find all or something like this. Otherwise, if it's not empty, then we create a query string. So we create a query for fields, first name, last name, or book title, and if it matches the pattern. So that means that if the pattern that we specified will match or the first name of the author, or the last name, or the title of any book that author holds, this author will be returned back, right? So this is super simple, super easy to understand. So we can also sort it if needed. So let's create a sort. So let's put here a sort, and then if sort field equals, so we'll use here a field that we used for sorting, right? So we have here an after, and we have a first name sort, first name sort. Let me make it a little bit larger, and then we call then, and just use the same field as same thing. We'll use the last name sort, right? So like this. So this will firstly by the first name and then by the last name. So and then we can of course call the fetch all. So this will have a search result, as you can see, search result by the author, and then you can call the get hits, and you'll get the list of authors, right? So now we can basically return it like this, and it's our complete query like this. So we can also use a paging as well. So you can pull you can call here fetch hits with the integer and then size. So if it's, or else, for example, 20, right? So you can put a 20 hits, and then just, yeah, you get the amount of authors as well. So yeah, but we'll use fetch all. We don't need to, actually we don't need to have a size for now, but it's a good idea to have a size, so you can do a paging or something like this, or limit if you only want to show the first 5, for example, or something like this. But yeah, so we'll remove it for now. So we have this, and this will search for the authors, of course, and let me come up with some authors, and after that I'll create a insert SQL. So in a few seconds I come up with this interesting list. So we have Stuart Douglas, Guillaume Smet, Clement Escoffier, Georgios Androunakis, and this is some of the developers of the Quarkus. And we have a few books here, mostly related to Quarkus. I would actually read some of them, or articles, whatever. So we have it. So let's restart our app. Actually, let's go to the terminal, call maven Quarkus dev. And so as you remember, the import SQL itself will be executed once you restart the app or change it a little bit. And you'll see that we have this Hibernate Search mass index book ID loading 1 going to reindex 8 entities. And after a few seconds, you can see that after 0.2 milliseconds, but seconds, you have a reindexes 8 entities. And yeah, this time it started a little bit slower because again it's Java, so if we create a native animation, we actually can do it as well with the Elasticsearch. So let's just firstly let's try the our search. So we have this book resource, right? Author index. Let's go to Postman book author index. Oh, sorry, search. So we want to have a pattern. So firstly, if you just call it search without nothing, we'll have this problem. I forgot to put the index here. This is crucial, so don't forget to put it as in a book. So if we search by empty field, you will get all the 4 authors, as you can see. Or we can, of course, search for some pattern that we had. So let's go to import SQL. Let's see what we have here. So let's search for a Quarkify, right? And pattern will be, in our case, Quarkify. And we'll see that we have 1 author. So even though, so let's just imagine that you go to the Goodreads or some other service and you search for a field, you want to find the author, right? But you don't remember the name of the author. But okay, I remember that he wrote the Quarkify something. So you put a Quarkify and you expect it to get correct author back. So in our case, Guillaume Smet created the Quarkify your Java, right? And then there is also a book, as you can see, so it's outputs the book as well because we have mapping. So you'll get the books back as well. So he wrote 2 books as expected, how to switch from Spring to Quarkus and then Quarkify your Java. So yeah, you can do basically the same thing for everything. You can of course search for the Quarkus itself and you'll get more authors, in our case actually all of them. So because the Quarkus, I think Quarkus is literally in every. Oh, let's search for the Java itself. So you have the 2 authors that somehow use the Java name in the name or in the title of the book. So you have this one under 1 second in Java, living in the post-spring world of his Quarkus, and then of course the same author that we searched previously, Guillaume Smet, Quarkify your Java. So yeah, so that's basically the search itself. Let's actually also create a native image for testing, right? So another thing that I'll add here is we'll disable the SSL because first we don't use it, and the second one is that we don't want. So if you disable the SSL, basically the image will be smaller. So that's what we'll use. You don't need to make it as is, but let's also actually remove the tests as well because we don't want them here for now because they're not correct, but that's not the point of the lesson, right? So I'll go here, I'll close our Quarkus and then maven env package profile native, right? So I'll disable my fan control for a second and let's build our image, right? So just as a small recap, I decided to remove the SSL stuff because of the MySQL. So just if it's not working for you without the SSL, then just remove this line and it should be good. So let's start our Hibernate VM runner without anything. And it took 0.5 seconds to start everything that we had basically, right? This large chunk of stuff. And the problem is that we have a database here, right? And so there will be nothing right now because of the prod. So for the prod, by default, the resolution target will be as is, but because we haven't imported the SQL itself, right? So you need to specify for the target that you want to you want to include this import SQL if you need to. In our case, we haven't specified it, but we can execute everything like this. So as you can see, it took only 0.4 seconds. We haven't included the import SQL, so there is nothing to index basically. But yeah, you can see the difference in the startup time with the Quarkus, and still it's possible even with 0.4 seconds. It's useful for the Lambda functions or something like this. So yeah, now you know how to use the Hibernate search with the Elasticsearch itself. and you know how to make indexed entities and how to search by the with the search session, right? So search session search, you can specify a predicate, like what to match with what fields it should match and what to resort, and also sort, of course. So yeah, hope you enjoyed. I'll see you in the next video.